All right, so we took out box's cover, took off the cover, and this is what we had inside. I had these switches in there too for basically the earlier purpose. But what we're going to do is change this out in kind of this way. So we've got the, say the outside of the box, right? Okay. And then we have, let's orientate it this way. We have a jack here, and two more, right? So we got 4 jacks in total. For the purposes of this diagram, we won't show the ground. All the grounds are basically connected all in parallel, so there's no reason to show that. We'll just show basically the tip connections off of each one of these. Okay, and then in these 2 holes right here that used to have those double pull, double throw switches, we're going to put in a couple of potentiometers. Okay, these representing the lugs of the potentiometers, and obviously these are going to be going to the ground as well, right? So we'll have potentiometers one end of the trace of the pot to ground, as you would do on a standard pot. All right, so looking at the box, this side here would be the reverb out, and this side would be the dry out, okay, as it sits on the board. So then these two, this would be the input from the 2 compressors right here. So we'll label that in from the comps, right? And then we're going to have this to be, we'll use this as the send to the reverb. And then we'll probably just use, let's say this one right here as the return from the reverb. Okay? And then this jack will just plug up. We'll get a little plastic hole plug there from the Home Depot and close it off. Or we'll just leave it there with a hole in it so that animals can crawl in there and have someplace warm to sleep in the winter. All right, so basically it's very simple wiring, right? So in from the capacitors. What I'll probably end up doing is I'm going to put, going to get a little tiny isolation transformer, right? And this is going to be ISO, all right, with the input and output side, right? So this will be the primary, and this will be the secondary. All right, so the primary side, we're going to have one side going to ground. All right, and we're going to join, obviously, the in from the compressors, so it could split off to go to the reverb. It'll also split off to go to the primary of the isolation transformer. The secondary of which, I don't think there's any need to put a switch to flip the polarity. But, you know, if you wanted to put a switch and make it more versatile for another board, that's fine. But we're just going to hardwire it in the way that's corrected in phase. I'm pretty sure that the Lexicon unit's input is in phase with the output, but sometimes they're not, and that can cause a problem when you're combining signals. But I'm pretty sure that they should be in phase with each other, and it won't present a problem. But also having the ground isolation would be interesting as well to have. All right, so we can put, for the dry out here, we're going to use, we have isolated jacks here, right? So we can disconnect this particular jack from its case ground and just connect it as such. So we'll have the dry out, you'll have one going to, well, excuse me, that is incorrect. You'll have one of those going to the ground, rather, right? Okay? And then this lug or rather this part of the transformer will go into the potentiometers, beginning of the trace, and then the wiper will be connected to the dry out. So we're placing the potentiometer on the secondary of the isolation transformer, right? So again, we're coming in from the compressors, splitting in two directions. One way going to this jack, which will go to the reverb unit. The other way going into the primary of the isolation transformer. The isolation transformer will be connected to a potentiometer and then to the dry out. So that'll give us a variable leveled signal, which is electrically or ground isolated from the other side. So that'll, help if we're going to end up with a ground loop, or, just in a lot of situations, it'll be a good thing to have. And if we have a phase issue, we can flip them, and that'll also be cool. All right, so then the return from the reverb is going to be very simple. We'll have the return from the reverb, which will enter our potentiometer. The output from the wiper will go to the reverb out, so we'll be able to set the level for that. So it's really a very simple, just basic box here that we're going to build, but it'll be useful for us to really kind of dial in how wet we want our other side to be. All right, so I'm going to go ahead and start wiring this thing up, and we'll see you when it's ready. Did a little bit of wiring. In a quick change, we did end up putting in a phase switch to flip the phase of one of the outputs, and we've got it transformer isolated as we were talking about before, and the two potentiometers, which will be able to give us the ability to adjust the levels for both outputs. So yeah, it's very simple adding the transformer. Basically, you got a primary side and a secondary side hooked directly to the potentiometer, primary side hooked directly to the input, and then the phase reversal switch is really something that's, well, I'll just draw you up one real quick. It's really a simple thing. I'm sure most of you know how to do this, but we'll always draw it just for people that may not, right? So let's say this is your switch, right? A double pole, double throw, right? This is some very basic sort of, switching concept. So you got a double pole, double throw, and these are your terminals, okay? Looking at the back of the switch. So if I were to have, I think I've got another switch here on the table somewhere. Let's see. Where is another switch? Here we go. All right, so we got another switch in a bag here. But basically, as you can see, the switch itself, let me shut off this light so we don't have so many shadows. There we go. Has the 6 terminals on it, the center terminals being the common, and the outside being the switched terminals. And they're divided into 2 sets of switches, right? 2 double pole, double throws from vertically separated. So you have these 3 operating as one switch, and these 3 operating as another switch, and they're insulated from one another. Center conductor making contact with either of the outsides, all right? So that's represented here. We can just show you real quick. Grab a pen here. This is the insulation, so that these 2 sides are isolated, and then you'll basically have, a switch going in this direction, right? All right, from common to the outside lugs. Now, basically, there's a couple of ways you could do it, and, that really depends upon, let's say, what you find more convenient in your layout, but the principle is basically to switch one lead for another lead where it's connected. So if you have, let's say, a positive source here and a negative source here, right? And you want them on the output, right? This is your output, so to speak, to be variable depending upon which way you switch it, for this side to be positive or this side to be negative, and vice versa. Really what you do is just basically draw an X, right? Like so. And then you would connect positive and negative. So now you would see as these sides are connected, right? You would have the negative on this side, and you would have the positive on this side. When you flip the switch again, you would have the positive then, right? Connected to this. So this would be positive. and this would be negative. So that is basically a flipper, a phase switch, a polarity switch, whatever you want to call it. Very rudimentary, basic sort of stuff, but drawing it out is always good. So with the transformer, you can flip the phase as the two legs of the secondary are in fact out of phase with each other. So if you find, for instance, that your amp is sounding, one side is sounding, or the whole thing's sounding thin, that may be due to a phase imbalance, and you'll be able to tell very obviously, without the need of a scope to see what the phase angles are. Just using your ears, you'll be able to tell obviously which one of these presents the stronger signal. It'd be kind of like connecting two of your stereo speakers in reverse, where you would have the positive connected the positive and negative to negative one speaker and the reverse on the other. You notice all your bass disappears, right? That's out of phase. So very simply, this is a corrective measure to take care of that if in fact we find that the input of the lexicon is out of phase with the output. Or if you're running in, let's say, into two amplifiers. Let's say you wanted to run this into a Fender and a Marshall, right? This side running into a Fender, this side running into a Marshall. For some reason, they run out of phase with each other. So having that phase switch is something that you'd want to do. Also, if your two amplifiers are, let's say, independent enough of one another but share a common ground, you might find that your unit hums, and to have that isolation there from ground will also provide a hum-free performance. You could also install another switch to reconnect ground, but we're not doing it for this one. So I think we can go ahead and button this guy up, put the cover back on, and I think we're about ready to start placing everything on the board itself and begin some of the basic layout. So we'll see you then.